Hi there, welcome to another video from the GMAT guy. And this video is another concept video in which we will discuss fractions, ratios, and decimals. Right? So how are these three things related to each other? How are they related to percentage? And then we'll look at a couple of problems of how to use and apply these things in a question. So, first thing is fractions. What's a fraction? When I say 1 over 4, what does this mean? Well, if you have 4 marbles, 1, and you pick 1 out of these 4, that's 1 over 4, right? 1/4. This can be converted into, a fraction is basically always expressed in its simplest form. So, even if you had, for example, 2 out of 8, let's say you pick these two, this selection is 2 over 8, and 2 and 8 can cancel. You can divide both these numbers by 2, which makes them 1 over 4. And so these two situations are actually identical. Both are, you're taking 1/4 of the total. Right, now the fraction is always out of something, and that is one important thing. Second thing is, many students, like many people actually, when they're preparing for GMAT, they've forgotten fractions that they did in primary school. So they have some struggling to do when they have to add fractions or subtract fractions or multiply, divide fractions. So I'm going to go through these two things quickly. So when you do half plus 1/3, how do you add them up? What you have to do is you have to make the denominators the same. You have to make common denominator. So 2 and 3, that's where you think of multiples. 2 and 3, the common multiple is 6. So you convert this to 3 out of 6 plus, right, you multiply 2 by 3 and you multiply 1 also by 3. So it becomes 3 over 6, and 3 over 6 is nothing but half. 3 out of 6 is half. 1/3 is nothing but 2 over 6. When the denominators are the same, that's when you can add them and you get 5 over 6. This is how you add, and this is the same way you subtract. How do you multiply? Multiplying is easier. You just go linear, straightforward. 1 times 1 over 1, 2 times 3, and you get 1 over 6. Right? How do you divide? Divide is, let's say if you want to do half divided by 1/3, this actually gets converted into multiplication. What you have to do is that this gets converted to half times 3 over 1. You flip the divisor, okay, the one that you're dividing by, and then you multiply, just as we discussed before, 3 over 2. So what this meant is 50 was divided by, let's say, 17. 1/3 is 33, sorry, roughly 33%. 50 divided by 133 roughly gave you 1.5, and that's what it means, 1.5 or 150%. So 50 is 150% of 33. That is another time, we'll discuss that in percentage videos, but that's how they are all related. Ratios. Before looking at the problem, let's just quickly look at ratio as well. Ratios are just fractions. Okay, so when you say half, this can be converted into 1:2. That's a ratio. So if I say, let's say there's a box and it has 3 red balls, okay, and then 4 blue balls. Okay, so the ratio of red to blue is 3:4. A ratio is also expressed in its simplest term. So even if you had, like, let's say 6 red, and then you have 4 more blue, the ratio would have been 6:8. You can divide both these numbers by 2 to give you 3:4. These two are equal, right? And a ratio can be converted into a fraction, thinking of this way: red over blue red is to blue could be written as red over blue, and that would become 3:4 would become 3/4, right? This would make sense. If I take blue on the other side, cross multiply, I get red is equal to 3/4 of blue. And now this makes sense. The number of red marbles is 3/4 or 75%, 3/4 of how many ever we have blue marbles, which was right? So this way you can cross multiply them, and they move, and that's why it's easy to handle them, right? So that's ratio. Good. So we've looked at fractions and ratios in under 5 or 6 minutes. Let's take a look at a couple of problems, and then we'll discuss one other thing about like how to convert decimals into a fraction. And then you're good to go for looking at GMAT problems. The present ratio of students to teachers at a certain school is 30:1. Okay, now the ratio is 30:1, right? But we don't know the actual number. The actual number of students could be 30, then the teachers would be 1. Or the number of students could be 60, teachers could be 2. Students could be 90, teachers could be 3, and so on. So ratio is basically a simplest, they have actually we are looking at common multiple, like the multiples of 30 and 1, and so it could be anything, right? So we don't know the actual number. If the student enrollment were to increase by 50 students, so what you would do to handle this kind of a situation is you would let the number of students be 30x, and therefore the number of teachers is x. The student enrollment increases by 50, so 30x plus 50 students, so 50 are added to the absolute number of students, and the number of teachers were to increase by 5, so you did x plus 5. The ratio of students to teachers would then be 25:1. Okay, so these two numbers are basically in a ratio which means 25:1. You can actually make this into a fraction and calculate x, so it becomes 30x plus 50 over x plus 5 is equal to 25/1. You cross multiply, and what you get is 30x plus 50 is equal to 25x. Let me look at the equation again. 25x plus 25 into 5 is 125. You subtract 25x, so you get 5x is equal to 75. X is equal to 15. Boom. So we've solved it. Let's see what they need. What is the present number of teachers? 15. Great. E is the answer. And that's it. That's how you solve it, right? Easy. Another one. Let's look at how fractions are worked with. And this we'll also discuss a bit of how to approach a word problem. When you are looking at GMAT questions, more than the formulae, what's going to trouble you is the words. They're going to be very subtle about it, and if you read the question wrongly, interpret it wrongly, and if you don't follow the story, then you might end up using the wrong formula in the wrong place. So formula is not the main thing. That's why in my videos you must have seen the formula to remember, or the formulae or the trick or the concepts are very simple, one or two, and more often it's about the approach. And so in this question you're going to look at that. A certain collector sold 5/8 of her paintings. So she sold 5/8. Now there is one option, there are two approaches I can take. At this point, right after, I have not even read the question, I'm actually just reading as I'm talking to you. A certain collector sold 5/8 of her paintings. I can either deal it with in fractions, or I can convert this into percentage, because I love percentage. So what I would do is, well, 8 is slightly difficult. Let's keep it in fractions. So sold, so if she had a total of 8 paintings, she sold 5 of them. That's what they're saying, including 2/3 of her impressionist paintings. So she has some number of impressionist paintings, and 2/3 are sold. So 2/3 out of these 5, 2/3 of these are impressionist paintings, which are I don't know how many there are. If 3/5 of her paintings were impressionist, okay, great. So what they've given me is that I is equal to 3/5 of total. Okay, so you have got a connection between I and T. T and sold, sold and I. Nice, so all four of them are connected to each other. That were not sold. So the question is, how many of these were not sold? Okay. So one quick way to work with this, because you are dealing with percentages and it's kind of tricky, is to do it in percentage. Okay, so I'm going to quickly do this in percent. I'm going to do the reverse. I'm going to take total as not 5 and 8. I'm just going to take it as 8, 3 and 5 are my denominators. So I'm going to take a number which is divisible by all three of these. So a common multiple of 3, 5 and 8. 15 and 8 would be 120. Great, so let's take 120. Let's say the total number of paintings is 120. How many are sold? Sold would be 5/8. That would be 75, right? That's 15 into 5 is 75. Great. 2/3 of her impressionist painting. I'm going to leave that for a bit. I'm going to start with this calculation here. Impressionist painting are 3/5 of 120. So I'm going to get 24 times 3, 72. 72 are impressionists. Okay. Out of which 2/3 are sold. So sold impressionists. This is not simple interest. Haha. It's 2/3 of 72. 24. So I get 48. Great. So I have 48 paintings out of the sold which are impressionists. What fraction of the paintings that were not sold were impressionists? So first of all, how many impressionist paintings are not sold? 1/3. So I'm going to look at how many impressionist paintings are not sold. Not sold is 24, right? 1/3. And how many paintings, what fraction of paintings? So we need to calculate this. We need to calculate how many impressionist paintings were not sold divided by how many were not sold, right? Of the fraction of impressionist painting out of all the paintings that were not sold. So I have that. Numerator is 24. How many are not sold? I just have to do total minus the sold. Not sold is 120 minus 75, right? And that is 25, 45. Great. So this fraction becomes 24 over 45. That is, if you divide by 3, you get 8 and 15. 8 over 15 should be the answer. And that is it. D is the answer. You've solved the problem. So that's how you actually end up solving a problem in fractions. You can actually use numbers, easy numbers, how to calculate them, how to actually think through the problem without getting confused, because you have so many things. But most importantly, you should have noticed, take note of how I have related and broken down the wordings. So 2/3 of her impressionist paintings, so 2/3 of I. Impressionist paintings were 3/5 of the total. So what we discussed in the percentage video of A% of B is C, same applies to percentage as well. Okay, now 1 or 2 quick things about decimals and then we are good to go, right? If you have 2.35 and you want to calculate what is the percentage of 2.35 over 5, right? And you want to calculate the percentage. What you have to do is you multiply both the numbers by 100 to get rid of the decimal. 235 over 500. That's it. You convert it into a fraction. This wouldn't have made much sense. So let's try it again. If I have 1.004, what I want to do is I want to convert this into a fraction to calculate something, right? I want to get rid of decimals because I hate decimals. So what I will do is I want to get this decimal to move 1, 2, and 3. I want to move it past the 4 so that the number completely becomes whole number, right? So what I need to do for each of these moves, I need to multiply it to 10. Multiply to 10. Multiply by 10. So this will become 1.004. This is over 1, remember. But I don't want to change the value because I can't just randomly multiply by 10 because the number is changing, right? But to compensate for that, what we do is we multiply both the numerator and the denominator. So effectively, we are multiplying this by 1. what we get is 1004 over 1000. Now you can simplify this. This can become 502 over 500, or 251 over 250, and that's your fraction. And then you can continue on solving from this. So that's something to do about decimals. Now, one more thing to note about decimals. Let me just write it out so that I follow my own little system here. Okay. There is the recurring decimal and the non-recurring decimal. Right. And this is one important trick when you have to terminating decimal, or in other words, like you might have seen some question that out of these three, 1 over 5, 1 over 4, which of these three is a terminating decimal? So terminating and recurring. Recurring means non-terminating. From a GMAT perspective, anything that goes 1 or 0 point it never ends. So it goes 1, 4, 3, 2, 1, 5, blah 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 blah. This ends. It's a terminating decimal. It terminates 0.2. 1 over 4 also terminates. It's 0.25. While 1 over 3 is 0.333, and that keeps running. It's just 3 never ending. This is a recurring decimal. 0.333 is a recurring decimal because it repeats. 0.143215, there's no pattern, then it's a non-terminating decimal. And these two are terminating decimals. The trick you need to know is that whenever you have to always look at the denominator of the fraction. Doesn't matter whatever is there in the numerator. Who cares? Nobody cares. Okay, so don't look at the numerator. Look at the denominator. If there are in the denominator, when you simplify, so the way it works is you have to first simplify the fraction, bring it to its simplest form. So if I have 4 over 6, I simplify this, right? I bring it to 2 over 3, and then I look at the denominator. If the denominator has prime numbers 2 and 5 only, then it's going to be a terminating decimal. If the denominator in the simplified version has leftover prime numbers like 3, 7, 11, 13, 17, and all the other ugly ones, and they haven't cancelled out, these are going to be non-terminating decimals. Okay, so that is a cakewalk. Easy peasy, now you've got it. Alright, thank you for watching this video, and I hope you can apply these simple concepts that we've discussed in questions when you practice. Okay, alright, see you in the next video. Bye bye.